Hey guys, welcome to the second video for chapter 7. We're still working on trig proofs. I want to start this by looking at an example. So if I asked you to find the cos of 45, you guys have no trouble with that, right? You get root 2 over 2. If I asked you to find the cos of, say, 60 degrees, once again, no problem with that, 1/2. If I asked you to find the cos of 45 degrees plus 60 degrees, some of you may say, well, perhaps maybe that's just the cos of 45 plus the cos of 60. But as mathematicians, we know better than to assume that we can distribute a trig function. And the reality is you can't. This is not the same thing as the cos of 105, which is what this actually is. Okay. So then how do we figure that out? Because I don't expect you guys to know the cos of 105 off the top of your head, but we can do it by looking at these two smaller angles that we do know. So the question today is going to be, how do we find the cos or sine or tan or secant or cosecant when I'm adding or when I'm subtracting two angles inside? So how do I do this? Sorry, this is an alpha and a beta. So how do I do that when I am, adding or subtracting inside? And again, I can do this for any trig function. So, okay, so let's build that. So first of all, we need a scenario in which we have the difference of, like an angle that is a difference or a sum. So look at this picture. I've got 2 points, A and B. If I look at this point B, it has an angle beta associated with it. See that little angle that just goes, this acute one that goes from here to here, okay? And then point A has an angle alpha associated with it, so it's all of that, right? So if I want to find the measure of the angle AOB, which is the angle between these two, then I would have to do the big angle minus the little one so that I just get this little part. So that's important to note because that's how I'm going to get an alpha minus beta situation. So first of all, that's where I'm coming from. Okay. Also, we need to note what these actual points are. So A, remember, if you want to get the coordinates for this point, you're going to do the cos of the angle for the x and the sine of the angle for the y. So if I wanted to find the points for A, that would be the cos for the angle of A, which is alpha, and then the sine of the angle would be the y value, which means that beta, or the B point, excuse me, is easy as well. It's whatever the cos of angle B is, beta, and then the sine of whatever beta is. Now, guys, you just have to watch this. You do not need to take notes on this. This is just one of those where you can kind of watch and soak it in. Okay, so what are two different ways to find the length of AB? You might think, well, what the heck does length have to do with this stuff? But trust me, it's how we created a proof of how these identities work. Okay, so this is what I'm looking for. How do I express that distance? Well, one of those you learned in the past unit using law of cosines, right? Remember, if you want to find a side and you have two sides in an angle, you could do that. So first of all, let's see how we would go about doing that. Well, first of all, if this is, and we are putting this, we can just put it on the unit circle. We could put it on any circle we wanted, but we'll let A and B be on the unit circle. If that's the case, then we know that this length from O to A is 1. We also know from O to B is 1, and O to A is also 1. So we know those two sides, and we know the angle in between. We're going to express it as alpha minus beta. So then we're going to use that law of cosines for this first guy. So LC for law of cosines. So law of cosines would say opposite sides squared, so AB squared, is equal to, remember, the two legs squared and added, so that would be 1 squared plus 1 squared, minus 2 times leg times the cos of the angle between them. And remember, the angle between them is this one that we created, alpha minus beta. Okay, so I'm going to simplify that real quick to just 1 plus 1, so 2 minus, and this whole thing is 2 cos alpha minus beta. This part is the crucial part because this is where I'm actually introducing this cosine where I have a difference inside, right? That's important. If I didn't do that, I wouldn't be able to introduce that. Okay, so how else can I find the distance between 2 points? This goes way back to geometry. Distance between 2 points is just Pythagorean theorem, right? So we would need the distance squared, if you remember, is the change in x squared plus the change in y squared. So that's what we're going to do here. But it's a little tricky because of all these variables. Okay, so the change between for the x values, so the change in x is going to be cos alpha minus cos beta, right? That would be your change in x squared plus the change in y's would be sine alpha minus sine beta squared. Now, usually if we just did distance, we would square root. But again, here, instead of doing the length of AB, we're leaving it AB squared so that we don't have to deal with the square roots and then square it again. So that's why you're seeing the squared part. Okay, so now we got to simplify this. And this is going to take a minute. Okay, so I'm going to square this quantity. Remember, when you square a quantity, you square the first term. The middle term is 2. That looks kind of like a 2, so I'll do that again. The middle term looks like a 2 cos alpha, the first term, times the second term, right? It's 2 of the product, then plus the second term squared. You can do this slowly if you need to, but that's how we square a quantity. Just make sure that you have the middle term. My second quantity squared, again, I have 2 of those middle terms, and then plus sine squared. Okay, now we have some simplifying to do because let's see if I can use some color here to help you guys recognize some things we can do. What do you notice about those two partnerships? Cos squared alpha plus sine squared alpha is 1. Cos squared beta plus sine squared beta is also 1. And then I have left minus 2 cos alpha cos beta minus 2 sine alpha sine beta. Okay, so 2 minus 2 cos alpha cos beta. Now you might be saying, this is crazy. How would I ever come up with this? Remember, mathematicians spent years studying ways to get these identities to work. So I'm showing you in one moment what they took a lot of time to do. Okay, so now I have 2 expressions for the same thing. I have this guy that gave me the length, and I have this guy that gave me a relationship on the length. So what I'm going to do, as you can imagine, if I have 2 things that are equal, is set them equal. And then I'm going to try to, remember, the whole point here was to try to figure this out. I'm trying to figure out what this is equal to, because we know it's not just distributive property. Okay, so first of all, the 2's are going to cancel if I try to move them. Second, look at this. I can divide everybody on both sides, every term, this term, this term, and this term by a -2. And when I do that, boom, I have my identity. The cos of alpha minus beta, this divided by a -2, cos alpha, cos beta, minus 2 sine alpha, sine beta. Yay, we did it. This is it. Here's the expansion. Look at this, guys. It wasn't the distributive property. This was not just cos alpha minus cos beta. It's all of this. This is one of those identities that we're going to use. So just to show you how we can use this, and then I'm going to come back to this. So in that first example, I said, what if I wanted cos of 45? I said plus 60, but we could also do minus 60. Then that means that, again, this isn't distributive property, but you could do cos of the first angle times cos of the second angle. Oops, I just noticed something, guys. My bad. This one, I forgot to divide that guy by 2. So this one should have been, sorry, plus sine. Huge deal. Yikes. Okay. So then this should have been, so then it would be plus sine of the first angle, alpha, times sine of the second angle, 60. Okay. Notice it went from being minus to a plus in between, so that's really important. I'm so sorry that I marked it wrong to begin with. And here we've got the same. Okay, so then you could go back and do it. You know the cos of 45, root 2 over 2. You know the cos of 60, 1/2. You know the sine of 45, root 2 over 2, and you know the sine of 60, root 3 over 2. So then you can simplify. I get root 2 over, careful, 2 times 2, 4. Root 2 times root 3 is root 6 over 4. So your final answer would be root 2 plus root 6 over 4. Look at that. Perfect, exact, lovely. Okay, so that's the difference. But let's talk about the sum. So what if it was cos of alpha plus beta? Good news, we don't have to do that long proof again. If I wanted to change this into, that was just me going to list it again. Remember, the identity was cos of the first, cos of the second. So cos, switch plus sine of the first, sine of the second. So there's the original one. Okay. If we want to do, if we want to do the others, we're going to have to know some of this information. So you have to remember that cos of a negative angle, cosine, remember, is an even function. So even if you have a negative inside, that's the same as cos of theta. Sine is odd though. So when you do a negative inside for sine, it becomes the negative version of sine. That's important. These are cofunctions. Remember, cos of pi over 2 minus theta is just sine. It's its cofunction. And sine of pi over 2 minus theta is cos, its cofunction. You'll need those in a moment. Okay, so let's see. I think I do. Yep. So again, we already know this guy. The difference is cos the first, cos the second, plus sine the first, sine the second. If I wanted to do the addition, I'm going to do addition, but I'm going to do it using subtraction since I already know that formula. But I'll make this guy a negative b because then technically that's subtraction, but it actually comes back out to this. Do you guys see that? So if I use subtraction, but make it a negative b, negative beta, technically that's the same as alpha, or alpha plus beta. I need everybody to see that. So to figure out what the plus version is, I'm going to do minus, but negative beta. Okay, so then I'm going to expand it using my same formula. So that would be cos of the first, alpha, times cos of the second. But remember, the second now is negative beta, plus sine of the first times sine of the second, which again now is negative beta. Now this is where those odd and even functions come in, right? So cos of alpha times, because cos is even, it's the same as just positive beta. So you can just flip it. A negative inside a sine, though, becomes negative the positive. So that negative here would bring a negative out front. Okay, so there's your identity. So what do you notice about, look at the minus version, the subtraction, and the plus version. They're almost identical except what? Yeah, the minus version has a plus in the middle and the plus version has a minus in the middle. So that's an easy way to remember the cos. We call this the sum and the difference. It's always cos and sine. The question is just, is it positive or negative? And it switches. So if it was negative here, a minus here, it becomes a plus there. If it was plus, it becomes minus. Okay. Now let's do sine. So if we want to do sine, we're going to do this as a cos value that we know. Remember from the previous place, we know that if you want to do the sine of something, that's the same as cos of pi over 2 minus theta. So this is what I'm going to do. Instead of sine, I'm going to replace that with a cos, but of pi over 2 minus theta. Okay, so again, I had sine of alpha plus beta, and I changed that to cos of the cofunction, so pi over 2 minus this. Now I'm going to do one more little piece here before I start, which is I'm going to go ahead and distribute the negative, and I'm going to choose to group these two together as my first angle, and then I'll use beta as my second. So I'm going to treat this as a subtraction. Okay, does everybody see that? I multiplied it through, and then I'm choosing to group those two together. Okay, there's a reason why that I needed to do that, but I'm not going to go into that today. Okay, so then I'm going to do my cos. So remember, here's your first angle, here's your second. So cosine of a difference is cos of the first angle. The whole first angle is pi over 2 minus alpha times the cos of the second. Because it's subtraction, it's plus sine of the first angle times sine of the second. Now we have some cleaning up to do. Cos of pi over 2 minus alpha. Remember, this is a cofunction, so this is really just sine. Cofunction. This is a cofunction. This sine of pi over 2 minus alpha is the same as cos alpha. And there you have it, guys. This is your formula for the sine sum. So if you want to add two angles inside, this is your expansion. Notice it is different from the cos. It's sine of the first cos plus cos of the first sine. This one, I always say sine, cos, sine, and it's always, the first angle, the second, the first angle, the second. Notice here, when it's addition, it's state addition. Interesting. I wonder if it'll stay that way or flip for subtraction. So for subtraction, we have an easier time of doing it because now that we know this, we can use this. So once again, to do subtraction, I'm actually going to do plus, since I already know how to do addition, the negative. So I get to do it as addition. So here we go. I would do sine of the first. Remember, the expansion is sine times cos of the second. So I'm going to do cos of negative beta, the second, plus cos of the first, cos of alpha, times sine of the second, negative beta. So I'm following this rule because that's what the rule I'm using. So then remember, a negative inside of a cos, it's an even function, so it stays cos. This is odd, so that's going to bring a negative out front of this whole term. So there we go. So look what happened. Same exact expansion, sine, cos, sine, except because it's subtraction, it's subtraction. Okay, and these are listed on your identity sheet, and we're going to use them so much that you'll get really comfortable with them. Oops. Last but not least, so if we wanted to find a formula for tan of alpha plus beta, how can we use what we already know? Well, again, we can use the two identities that we already know. This one can get a little busy, but I can use the sine, like let's just do the sum. I can use the sum expansion, so sine alpha cos beta plus, I'm going to just do the addition one, plus cos alpha sine beta. The bottom is cos, remember? And then if it's plus, which I'm doing addition, it's actually minus sine. Okay. So this one's kind of wild because this is fine, right? This would work, but it would be really great if I could express things in terms of tangent. So that's my plan. I'm going to try to change these. And again, you guys don't have to memorize how to do this. It's going to be using it, but I'm going to show you how we do that. So if I wanted to introduce tangent here, I'm going to multiply by some interesting things. Really weird, but just trust me. I'm going to multiply the top and the bottom of this fraction, sine beta, by 1 over cos alpha cos beta. I'm doing that to the top and to the bottom. So remember, if I do the same thing to both, it doesn't actually change it. Okay. Whew, this is a long one. Again, you do not have to do this every time. This is just to help us understand how we got there. Okay. So this is where you're going to have to kind of look ahead at what I'm multiplying. Okay, so if I were to multiply this guy times this, I want everybody to be very careful at looking at this. This guy times the first here, you would end up with sine alpha cos beta over cos alpha cos beta. Plus, I'm going to go ahead and do this for everybody, and then we'll look at how this reduces. Again, mathematicians spend a lot of time looking for ways to simplify this. I do not expect you to know that this is the thing you should have chose today. It took a lot of work and a lot of time, and probably a lot of trial and error, honestly. Okay. Whew. Okay. So here we are. Now let's do some simplifying. Normally in proofs we would never cross anything out, but for the sake of being able to show you guys, I'm going to do that. So like notice those two cancel and those two cancel. These two completely cancel, and that's it. So what can we write from here? Well, if this is gone, this is just sine alpha over cos alpha, which sine over cos is tan. So that's tan of the first angle. Hey, there's somebody in terms of tan. If these cancel, you have sine of beta over cos beta, which is also a tan, but a beta. Over, this whole thing canceled. It's not 0 though, remember it's 1. And then minus sine alpha over cos alpha. Just this particular part is tan alpha, and just this particular part is tan beta. So there's your identity, guys. If you want to do the tan of alpha plus beta, it's the tan of the first plus the tan of the second over 1 minus tan first, tan second. If you wanted to do the subtraction version, it ends up being minus here and plus here. I'm not going to do a huge big proof of that, but there's your formula. Okay. Okay. So once again, you're going to get to practice actually doing these, but just to kind of show you quickly how this works. Like again, if I wanted to do what will happen is I will give you an angle that you can create. So I might say, what is the sine of like 195 degrees? And you'll go, I don't know. But your plan will be, well, what two angles could I split that into, maybe as addition or subtraction? That I do know. I'll give you a hint. If it ends in a 5, you're probably going to be using a 45, right? So then this would be, I could use 45, which is an angle I know, and I could use 150. I could also use, let's see, 135 and 60 would add up to 195. I have lots of options. Okay, I'm going to just go ahead and use this first one. So if I want to solve for this exact without having to plug it into my calculator, I'm going to use the identity. So the first thing I did was split it up into a sum. Then I'm going to apply the identity. The identity for sine, sine of the first, cos of the second. So sine, cos. The sine stays the same. And then it's sine, cos, cos, sine. And then it's first angle, second angle. So sine, cos, cosine. Okay, then we do it. Sine of 45, root 2 over 2. Cos of 150, careful. Cos of 150 is a 30-degree angle, which is a root through root 2, but be careful, it is negative. Whenever your angle's outside of the first quadrant, always double check if it's supposed to be positive or negative. Plus cos of 45, root 2 over 2. Sine of 150 is 1/2, and it is positive in the second quadrant. If you need to draw a little picture of where your two angles are, do it, so that you don't forget. So then I get negative root 6 over 4, multiplying, and root 2 over 4. So I could say negative root 6 plus root 2 over 4 for my final answer. And I could do the same thing for cos and tan. Again, we'll do more of these in class, and we have some other things that we'll expand on, but this is the general idea.